Number 75 is a hard problem, guys, and I should be clear right off the bat. I am not assigning this problem to you guys because I think it's one that you should have been able to get right off the bat. I would be very impressed if anybody was able to get this problem right on their own without the hint that they've given you. But I give you a problem like this every so often because I want you to kind of dig deep in these problems, and my hope is that by the end of it, you're going to go, oh, that was interesting. I wouldn't have thought of that on my own, but I now kind of see why they did it and why it works, so that maybe the next time you do see a problem of this layer of complexity, you might have some sense of how to do it. But this is definitely an outside-the-box problem. We've got this integral right here, and it's a weird one because there's only an x on one side of this entire thing here. Now, you might be tempted, don't write this down, guys, to rewrite this as an integral of maybe something like 1 plus the square root of x to the negative third power dx. Now that would be okay. And then you might say, all right, I'm just going to reverse the power rule. I'm going to make this 1 plus the square root of x to the negative second power, divide by that negative 2. That puts a negative 1/2 out in front. But now the problem is you would need to divide by the derivative within. And the derivative within is not constant. It's going to contain an x. And so when you do that, guys, that's going to end up giving you something that if you then turned around and differentiated would not match the original integrand. So that's another reason why this problem, why this problem is tough. Okay, so back to it, everybody. Let me get rid of all of this junk. And they did give us a hint on this problem, and I'd be stupid not to use that. So they said, to let go ahead and to let u equal, it would be the base of the exponent in the denominator, 1 plus the square root of x. Now that doesn't shock me here, guys, because the primary substitution now is going to be nice and simple. In fact, I'll start working on that right now. The integral of, and down on the bottom, the 1 plus the square root of x just becomes u, so we end up with a u cubed down there underneath. That part was easy. The hard part now is going to be the secondary substitution. We've got to get 1 dx, or really just dx, represented in terms of u's and or du's. So let's differentiate what we have here. Du is equal to, well, the derivative of 1 is 0, and here's where things get interesting. The derivative of the square root of x is 1 over 2 times the square root of x, with a dx at the end of all that. That 2 root x on the bottom right there is a problem for us. All right, so I kind of have that little issue going on right there. So I tell you what I really wanted right here was a 1 dx. So I'm going to move this 2 root x over to the other side and get 2 times the square root of x multiplied by du is equal to the 1 dx that we wanted. Now that's weird here, guys. I'm going to write something that I hardly ever write, but the substitution here is correct. The 1 dx, which is right here, gets replaced by 2 root x du. Well, I'm going to put the 2 out here. I guess I'm going to put the root x up here on the top and then the du at the end. And I just did something really, really dumb that I'm going to have to fix. I tried to get all of my x's represented here in terms of u's, and I got a lot of it, but now I have this mixed metaphor right here, guys, of both an x and a u in the same line. Now, I don't want the x right here. I want everything in terms of u. So the question becomes, can I go back to this original statement right here of u and get just plain x solved that way? And usually I would tell you to, work up here. Like, for example, go u minus 1 is equal to the square root of x. Actually, that might be what I needed right there. I thought I was going a different place, but I think that's it. U minus 1 is equal to the square root of x. That's what we needed on the top, guys, the square root of x. So, let me see here. 2 times the integral of. Now, my numerator, the square root of x, could become u minus 1. My denominator is u cubed, and there's a du at the end of this. Okay, so all of the x's and the dx have now been replaced by u's and du, and what I would probably do at this point, guys, is take advantage of the fact, this happens every so often, that our integrand here has a polynomial numerator and a monomial denominator. I would probably split this and make it u over u cubed minus a 1 over u cubed. Now the u over u cubed would simplify to a 1 over u squared, or u to the negative second power. And then minus 1 over u cubed would be u to the negative third power. And we're taking all that with respect to u. So I kind of feel like where we are right now is going to work just fine. It's maybe a little ugly, but certainly doable. I'll put a 2 here, start a set of brackets, and here we go. We're going to take this first u, raise the exponent by 1, and divide by that new exponent that puts a negative out in front. Minus a u, raise the power by 1, that's negative 2, and divide by that new exponent. So that's like multiplying by a negative 1/2. Well, here's the 1/2, and the fact that it's negative turns that minus into a plus. Close your bracket. That's the end of our antiderivative, and a plus c at the end of all that. So what I think I would do here, guys, is make that, it's really not important whether you distribute the 2 or not, but I think I'm going to try to do that. I'm going to distribute this 2 and deal with those negative exponents too. So I think this first term is now going to give me a negative 2, and then u to the negative first just becomes a positive u to the first power on bottom. And then we would have a plus now. 2 times the 1/2 would cancel each other out, and u to the negative second is a 1 over u squared plus c. And the last thing we would need to do then, guys, is to unsubstitute right here and make this a negative 2 over, and our initial substitution was to let u equal 1 plus the square root of x. So 1 plus root x would go there, and then a plus 1 over, and we'll leave that as a 1 plus root x quantity squared plus c. Okay, so that was an interesting problem. I'm not exactly sure that I used their hint exactly the way that they wanted to, because at some point they wanted us to show that dx was equal to 2 times u minus 1 du, but I think we got the point across right there, okay? So that was number 75, and sure enough, that looks like the answer that they have in the solutions manual, so we should feel pretty good about that one, guys. Okay, so there's number 75.